Today, the last talk is about replicating MySQL to ClickHouse. I won't promote ClickHouse too much here because it's about MySQL, but I will tell you why MySQL is so good to replicate from. So let's do that. So I am Arnaud and I lead the database team at Jump Trading. You can see that the slides have the Altinity logo. Altin is here. It's because we developed this with Altinity. And the main developers here today is County. And so if you raise bugs on the repo, you will see that he usually replies very quickly. So do I. So, yes, bit of introduction. Everybody knows what a transaction database is. Transactional database, row-based, B-tree, SQL, ACID, transaction. And examples of that are the well-known dolphin, the less-known elephant, etc. So, and ClickHouse, what is it? So, ClickHouse is a columnar database, so not row-based. The data structure is different, merge tree. Created 2009 in Russia by the Russian Yandex, nearly 39,000 stars on GitHub, so it's kind of popular. Real-time analytics, does real-time analytics. And if you want to know more about it, I recommend this paper that's recent. It's presented in China by Alexei, the founder of ClickHouse, and it has over 2,000 contributors, and I am one of them. Replication. So why would you want to do that? So you replicate between a primary and a replicas, data synchronization, obviously, between two same systems, homogeneous, between two different systems, which is the case today with ClickHouse. It's called heterogeneous replication. It's more difficult because it doesn't speak the same language, so you translate things. But thankfully, we have logical replication in MySQL, so that is easier. And that is log-based. Everybody knows the binary log that replicate the changes. And this is called CDC. So it's a fashionable term these days. Why replication? You can use replication for different purpose. One of them would be migration. So if you migrate from MySQL to ClickHouse, you may want to use that because it will allow you to synchronize the system, and then when they are in sync, you fail over, and then so migration would be one use case. It would, if you want to continuously synchronize between them. For example, you want to do OLTP in MySQL and you want to do OLAP in ClickHouse, you can run this process for forever. And then you will have decent analytics on ClickHouse, which you cannot really have easily in MySQL. And I'll show some examples. Fault tolerance can be a reason why you replicate from one data center to another. And if you have a plane that crashes on a data center, disaster recovery obviously is a use case. And it's probably the most interesting feature of MySQL. So it's a very useful building block. And like Simon probably knows that for operating a MySQL in production. So in the case of this project, because this is a project on GitHub, it's all about open source. What we wanted is no data loss, low latency between the systems. We wanted exactly once delivery, which is not easy. When you have Kafka, you know that there can be duplicates and stuff like that. And I'll show you how we achieved that. We wanted operational simplicity, like just a simple component, very easy to monitor and start and stop and troubleshoot. We wanted fault tolerance, so even though, for example, you can have two such components that are different data centers, they would read the binary log the same way that MySQL would do, and then they would write to another ClickHouse instance on another data center. So that is possible through MySQL application. And then we wanted this to be fully open source. In terms of design, few principles: keep it simple, stupid. We are an American company, so we like simple things. And then we use things like Docker, MySQL, Antler, anyone uses Antler here? Antler is actually a parser. So if you give it SQL, it will create an AST, so an abstract syntax tree. And so then from there, you have a data structure and then a tree, and then you can execute from it. Of course, the binary log is one of the giants. And we didn't want to reinvent the wheel. There are a lot of libraries that read the binary log and do the translation for you. And Debezium is the most famous, is in Java. And the reason is that it has multiple source. So you can do, if you adopt Debezium, you can read from Oracle, you can read from MongoDB, you can read from MariaDB, different. So that was one of the reasons we chose it. Okay, in terms of other design choices, keep it simple, stupid, one table to one table, just like MySQL application. Primary keys. If you don't have primary keys, it's very difficult to replicate. And in the case of ClickHouse, it will be just one row. So everything will be in one row. We support all data types, and we use the replacing merge tree, which is, I will abbreviate with RMT. I'll explain with the schema. And so what we also wanted is that eventually we wanted the same queries returning the same results. And what is less common, and which is probably unachievable in Postgres, is full DDL support. So if you add a colon, if you remove a colon, if you change the data type, if you send a trigger or something like that, the replicator should understand that it can be or cannot be translated. And if it's sensible to translate it in the right way, that will lead to correct results. That's kind of interesting. And then the time zone, it's not so simple. Usually in MySQL, you want the time zone to be the same. Here, the date are represented a different way. And so in ClickHouse, it's UTC, while in MySQL, it is sort of a string. So a string of numbers, and so it doesn't really have the time zone. It has if you turn it into a string, it gives you a date, but it doesn't tell you the time zone. You need to guess what the time zone was when it was written. So usually it's the time zone of the server, of course. But some people mix the time zones. Like we can have UTC and non-UTC. So it's all kind of interesting. So it's going to be application dependent. If you know it's UTC, then you will say, hey, because it's UTC. So that's how you solve the problem. But of course, the checksum are going to be different. The data is going to be different if you don't handle this correctly. Okay, other design choices. The replication state is in ClickHouse. That reminds something to people that know MySQL replication. With the info tables, right? Yeah. That are transactionals. And so we wanted the same syntax, like show replica status to show, views like that. I think it's replica source status these days. And then we want, that it works well, replication filter, checksum. Also, usually when you do synchronization like that, the simplest is just to set up and just wait for the system to synchronize through snapshots. But we have hundreds of terabytes to synchronize. So we build efficient dumpers and loaders at a position. And because we based on the MySQL position replication, we could just say, hey, replicate from that point in time. And so this way we managed to synchronize the system. And that works quite well. This is really on the shoulders of giants, all these things. Architecture. So I said Debezium allows you all kind of sources. In the middle, you have this container that runs Debezium, but also this Altinity component, which is a Java program. So the flow of information will be in MySQL binary log shipped to decoded by Debezium that registers as a client, replication client. And then it gets the events, and then those events are acquired as a library, like it's Debezium embedded to a Java program. So basically, you will get, your process will get a stream of events and DDL that you need to translate, and then that component also opens connections. It's a pool of connections to ClickHouse and applies those events. So it comes serialized, and then you can apply in parallel even if you don't care too much about consistency, but eventually it will be consistent. Any questions on that? Because the previous audience was a bit confused about how it works. No? Okay. So, in terms of implementation, one container using Docker Compose, Java Debezium, multi-threaded applier, eventually consistent, low latency. Easy. So that's the interesting bit where you see how we translated from one system to another. Of course, in MySQL, you don't have that, MySQL replication, but here it's heterogeneous. So you can see the table name is the same, the column names are the same, the data types are translated. By default in ClickHouse, it's not null, so we remove the not null, but if it's null, we make it nullable here. Then you have those auxiliary fields that are important for the kind of data structure that we have, which is a replacing merge tree. That has the version and is deleted. With a version field and an is deleted field, you can have a stream of inserts, and then you can have merge on reads, meaning that you can read that table and say, hey, ClickHouse, remove, only keep the latest version and only remove whatever is deleted. And so also ClickHouse in the background merges this information. So eventually those things will get physically removed, which is interesting. So yesterday's data probably has been fully merged, and so the reads can also be faster because so it can make all those assumptions. In terms of primary key, I said exactly once delivery. So we have the primary key here that is the same. We can pass the partition close and say, oh, partition on order date. Turns out that ClickHouse can do this, not declaratively, and it will generate a partition whenever there's an insert on that partition. Okay, is it clear for everybody? What we're doing here is kind of, yes?
So the primary key is same, but the version can still change, right? So how is it going to give you?
Yeah, so for example, an update would delete the row. It basically would, MySQL replication will give you the previous image. And so, oh, previous image, deleted, is deleted. And then increment the version for the new image. Right. And so this way, you can even not delete it because the engine would, we delete it for the sake of security, but because if the primary key doesn't change, you don't need that. But if the primary key change, you need to delete it because you will update the primary key. So it's kind of interesting stuff. Yeah.
Do you require do you require full RBR, or can you?
Yes,
can you do magic to hide it?
I didn't decide. Debezium does require full RBR.
Okay.
Yeah.
So
Sorry about that.
to hide that.
So, yeah, you can contribute to Debezium if you want. So, it's an open source project. We leverage that. Okay. So, why this presentation is relevant to this audience? Because MySQL is very good here in this exercise compared to other databases. It has excellent replication. It has excellent exporter called MySQL shell. It is battle tested. Debezium support is good. It is performant. It has a new feature which is called fast count, which I tried. So if you have a 1 billion table, you want to count it, you can, with a simple Python program, you can do it 30 times faster than if you run a regular count. And I'll show you how you can do that. And then everybody dealing with replication knows that you need a RBit. It's even in Google Cloud, for example, you have an RBit. So the RBit is just a table that is inserted on the primary every 10 seconds, every 30 seconds, every whatever. But in case of disconnection between the replica and the primary, show slave status, show replica status,
So
will give you random numbers.
Synchronization points.
Yeah. So you absolutely need that in all serious replication setup of whatever technology you have, like MySQL, Sybase, whatever. Yeah, so you need that.
It's included in replication now.
Now it's included. Oh, okay.
Not the same way, but yeah, it works the same way. But it has it's not another table, but it has R8 in the replication.
Okay, so that was
It's something like this.
There's an R8.
But this will be different.
yeah, it works with GTID. Because the position can be specified in GTID, like the client will understand where you want. So MySQL shell is very good. It exports in TSV format, Z-standard compression. Sorry for my dumper, but this is what we use. It's very good for that. If you need masquerading, yeah, maybe, but this is really serious, professional, battle-tested, proven. I dumped terabytes and terabytes of data using that. And I have a wrapper called MySQL dumper that dumps the data and load it using the ClickHouse loader. Okay, checksum. Interesting. If you want to test this, you need to verify that it's already difficult to replicate between MySQL and MySQL, but between a different system, the data types could be different, the nullability of the column could be different. Yeah.
MySQL shell does checksums.
Oh yeah, but does it checksum in ClickHouse? That's the thing. So it's to compare MySQL and ClickHouse. So you need to be. We're inspired by an article on Sisense, and I can show you if you're interested. You can do multi-threaded checks. If you can do consistent reads, you can do multi-threaded checksum. Here it's order independent because a select star doesn't give you necessarily the order. That was a design choice for the checksum. And it's good enough, right? If the table is synchronized and that check passes, yeah, maybe the order is different. Who cares, right? The data is there for analytics, especially. Yeah.
So how are you doing the checksum it's a moving target, right? So you're getting streaming bin logs.
Yeah, you can do a checksum on a partition that doesn't change. If you like, for example, or you can stop replication.
Yeah.
And then, yeah, then the replica where you stop replication is going to be the same as ClickHouse. And then you just,
Okay, sorry.
yeah. So and as you can spin up a replica very easily, then it's possible to do that. Okay. The fast count. So the fast count from 8 to 14, there's a specific variable that I'll show in the next slide. And it's in this, I learned that in this Protonar article. And then, it works on tables. So nowhere close. But it turns out a partition is a table. So you can parallelize on the partitions. So if you parallelize on the partition and you parallelize on the threads, you can do extremely fast counts, right? And that gives you a sort of idea that, the 3 billion that you have in one side, match the 3 billion. So it's reasonably good. Maybe the columns are slightly different, but it gives you a first order comparison.
But is it also faster on non-partition tables?
Yeah. So here's an example taken from Percona. So here you have nearly a 20 times speed up with 32 threads. So local InnoDB parallel read threads 32, and you see it's like 93 seconds and then 5 seconds. And if I do the math correctly, it's about 18, 19 times faster. And of course, if you have 64 core, you can do whatever you want. So, and you can parallelize. So if you look at the information schema, you see the partitions, you parallelize. And so I have a program that does that. It's in the Git repo. All right. Rbit must have, so everybody knows the Rbit. So I will go a little bit faster because I have a demo. Rbit looks like this. So you have the timestamp. The timestamp is even a string to account for the different time zone and stuff. All right. The goodies that we have in MySQL is automatic primary key. So if you have a schema you don't master, enable the generate invisible primary key from 8031. And then you will, even for the tables, like for example, Alembic version that do not have a primary key, you get one. And you can also annoy the developers with this nice little feature, which will basically give them an error if they create the schema. So you have either you cannot speak to them or you can speak to them, but you can get it working. And that again is recommended in any replication setup, you know. Without primary keys, you cannot do much. So that's the time for the demo. Let me check if it's gonna work. I think so. So I have here a container, so I'm gonna stop it. I should actually, it's waiting for ClickHouse to stop. Should have come from the previous demo. So basically this is Docker Compose, right? I'm also going to shut this because it will make the screen bigger. So what I do is Docker Compose down. Okay, everybody knows what Docker Compose down is. I'm removing the data. There's nothing on that computer and then I'm running. I said it was simple.
Didn't go well, I think.
Yeah, I'll clean up the stuff here, but it doesn't matter. Doesn't matter. But then I can tell you that here I would wipe out the data from MySQL and ClickHouse. Yeah, there could be some errors. So here what it's doing, it is actually replicating already because when I start the MySQL, I have an init file, and this init file will create inserts on the primary, and as you can see, it replicates. Okay? And so I have here MySQL command. I hope you guys see that. Is it big enough? I guess so. So I can make it bigger if need be. So I have those tables. It's, I don't know where it comes from, but I think it's a well-known schema. And if I do that here, so it's replicated just fine. So, what can I show you? I can show you that the count is about the same, right? Select, count star from, I'll focus on one table. You can assume that it works on the other table the same. So here I have 23. So I not only have replicated the schema, but I have replicated the data. Or here I have to do it again. This way, yeah. And so here I have 23 too. So I can even verify that it's correct, and I run the checksum. Right, the checksum are the same, so 23. I'll show at the end of the presentation how the checksum work in terms of debug. But from there, what I can show you is can do that. And so I have, if I do that on MySQL 2, let's focus on the last records, right? It's going to be ordered the same. So GRR here, Mr. Martin, contains the same information, so same primary key, same data. It just contains those helper fields that I discussed. So basically, this is the insertion time. It's always increasing. So that guarantees that the version is always, so any update that's coming is going to be bigger than the previous one. And so it has a kind of a counter there that's always increasing. It's relatively easy to get because the data is serialized. So, and then you have the is deleted 0. So let's do something fun. Instead, let's do a promotion. Let's promote everybody to senior and see what happens. Right? So here, the update went through MySQL, and now everybody is senior, including Martin. And so I'm going to check that this works here. So here on the ClickHouse side, yeah, 2. So no surprise. So what else can I show you? I can show you.
Question? You only see the last version, is that correct? You don't see like not. Do you have access to? You don't have access to previous versions.
No,
because you rewrite the role.
I can. Imagine that I'm writing to a merge tree. I don't lose the data, and then I can have a materialized view.
Okay,
Reinsert. So you can have the best of both worlds. So that's a good remark, because if you want to analyze 1 year of binary log, you could very well do that.
Yeah.
And then you would have every event, and this kind of analytics is difficult to get otherwise. Yeah. People wanted to have, audit logs That would be nice in terms of rights, at least. Okay. Let me do something real quick. Maybe just a delete, right? So you know that I have 23 employees. If I do that on, I need to do that on the MySQL side. So here I have 22, so I remove one. Here I need to be careful because the count should be the same, but I'm going to create to add a variable which is going to be final one, which is going to finalize, going to merge the information. And so in theory, it should be the same. Oh yeah, the first select is going, they're missing a S here, so it's 22. But suppose I'm doing final 0, it's possible that I'm going to see more. Final 0, 47. See, it's important to finalize. So when I read, it merges the data. So it removes the data that is still there. But if I do optimize now, or if I can even schedule and optimize every hour, I can do TTL recompress. So ClickHouse has a lot of goodies there. One thing I wanted to show you is doing a simple DDL, so adding a column. So we can do more complicated than that, but imagine that I add a higher date that is today. I should see it with this higher date is there, right? I can remove it. Like you understood, like I don't need to. This should be better. It should be tested and QA'd, and so it should be working. So that's the expectation. Now I'm going to do something risky. I'm going to rerun the checksum. Same. So you can see that the number of records decrease and the checksum is the same. So I'm pretty sure, I'm not 100% sure now that the table is this. But you can do that on a larger scale. If you want to know, I think that's about it. If you have questions, I can do dump and load, show you the dump and load, or I can show you the debug mode of this, which will show you the implementation. So the implementation you can see here, I think it should be the ClickHouse side, or MySQL side. Yes, this is ClickHouse side. So you can see that you have normalization here. Everything has a string. Then you compute the MD5, you could compute the XX hash 32 if you like. But here MD5 is a big enough X hash, and so you can turn this into a number, sum the number, gets the number, and then the count, the 4 numbers and the hash give you another MD5 checksum. And so then you can compare. On the MySQL side, it's kind of fast as well. Why? Because I leverage a feature which is called, the variables. The session variables can be incremented. So that's basically how PT table checksum works, but, normalized so that the dates have the same boundaries as ClickHouse and stuff like that. So it works. And so, yes, another thing that I can show you, which would conclude my presentation, would be let me do a dump using MySQL shell. So that's my program, basically. So my program is Python program, which is just a simple wrapper, would run MySQL shell. You see MySQL shell here? So you see MySQL shell. I generated a pretty complex JSON from the information I got from the schema, including the partitions and stuff, because you can filter by partition if you like. And then I pass this file, which is a temporary file in JSON, in Python, and then I run that, and then MySQL shell does it very fast, and I can even specify the number of threads. I didn't here, but I could specify 32, 30, 64, whatever. And then you see that it dumps it pretty quickly and turn it into TSV. The schema, you have the schema, you have the Z standard TSV there. And then you also have this weird file here that's called, I think this app.json here. Those familiar with Okay, it's not there. Yeah. Oh yeah, it's so weird that I need to put. Yeah, sorry. Oh no. I also need to.
In the home directory.
Yeah, in the home, Adant, db dump, and yeah, test, I think that's it. And you see position. GTID, server, binlog position, everything to restore it, consistent. You have everything. So I think that's it. What I can also do is a load using ClickHouse loader. Ooh, doesn't work. Expected, because I need to drop it, right? I need to drop the database. There's a security here. Like, you don't want to override a production database, right? So I drop it because I know it's in production. I run the load, boom. So it decodes the schema with Enter, turn it into, understand the AST, turn it into whatever, and load the TSV file with standard. TSV gzip standard with, and yeah, TSV, and then I think I can just run a checksum after the load. Yeah, works. Thank you for your time.